Welcome to Derivability. Today we're going to take a look at something called the triple scalar product for vectors. Okay, now if you've been watching some of my other videos, you know I did one on something we call the triple vector product, which is A cross B cross C, parentheses around the B and the C, B cross C, for instance. Okay, here we're going to do a dot, the cross product B cross C. And what we're going to find is that we can cycle through the A, B, and C, and we always get the same thing. In other words, as we go from this first version of the product, okay, we can put A in the place of C in the third position over here. Okay, B in the first position, and then C in the second position. Basically, we're just moving everything one place to the left, and then if you move off from the left, we cycle back over to the right. Okay, and then if we can prove it for one pair of these equalities, then it's true for all three. All right, so let me start with reminding you how we configure a cross product B cross C. Okay, you may be familiar with this determinant way of calculating a cross product. Okay, so this top row are my unit vectors I, J, K. Second row are the X, Y, Z components of the first vector in the cross product, and then the last row, the second vector in the cross product, Cx, Cy, Cz. Okay, now the actual vectors here are the top row I, J, K. What we are wanting to do is we are wanting to take the dot product of A with this. Okay, now A, of course, is equal to A sub xi plus A sub yj plus A sub zk. Okay, and we're dotting it into this cross product. Okay, now I'm not going to write the rest because well, you'll see why in a minute. Okay, but as far as this dot product is concerned, all we need are the I, J, K at the top. Okay, what that essentially does here, okay, we have A sub xi dotted with the I, A sub yj dotted with this j, and A sub zk dotted with that k. Okay, so basically what that amounts to is that the vector components A sub x, A sub y, and A sub z take the place of the ijk in the top row of the determinant. Okay, and then the vector components of B and C just stay where they are. Okay, so now our job is to calculate this determinant. Okay, all right, well, let's just do that now. Okay, we'll just do the determinant in the usual way, except we don't have I, J, K at the top. We have the vector components of A. All right, so first we'll do this positive diagonal. Okay, A sub x, B sub y, C sub z. Okay, now this positive diagonal. A sub y, B sub z, C sub x. Okay, and now this positive diagonal, A sub z, B sub x, C sub y. Okay, then we are going to do the negative diagonals. Okay, so let's do the main diagonal here next. Okay, so it's going to be minus A sub z, B sub y, C sub x. Okay, maybe some slightly different colors here on these diagonals now. Okay, so then minus a sub y, b sub x, c sub z. And then one more. Minus a sub x, b sub z, c sub y. Okay. All right. Now, yeah, a little bit of writing, but that's how we do determinants. Okay. All right. So what we want to prove here is that the determinant that we just got by doing A dot the grouping B cross C, okay, what we would like to do is prove that it's equal to one of these others. Okay. Now to do that, I'm going to need a little bit of clean space here. So let me wipe this up, and then we'll come back and finish this off. All right. Well, we're back now. Got some clean space. All right. So what I did was I copied that blue writing up near the top. Okay, there, that was the result of the determinant for A dot, the grouping B cross C. Okay, now in red, let me do B dot the grouping C cross A. All right, and of course we learned last time that we can replace the top row, IJK, of the usual cross product determinant with the components of the first vector that we're dotting the cross product with. Okay, so let's just go through this one. All right, and I don't know that I need to draw the diagonals here. We kind of reviewed how that goes to do the cross product, or rather the determinant, excuse me. So I'm just going to write these down here. Okay, so B sub x, C sub y, A sub z, plus B sub y, C sub z, A sub x, plus B sub z, C sub x, A sub y. Okay, now the negative diagonals. B sub z, C sub y, A sub x, minus B sub y, C sub x, A sub z. And then finally, minus B sub x, C sub z, A sub y. Okay. All right. Now, if it is true, as I have asserted, that we should get the same thing here, then we basically should have the same 6 terms, 3 positives and 3 negatives, maybe just in a different order of addition, or the individual terms. You know, may have the A, B's, and C's, X, Y, Z components in different orders. But let's just go through and then check that we really do have the same 6 terms in each one. Okay, so B sub x, C sub y, A sub z. Okay, those are those 2 guys. Okay, next, B sub y, C sub z, A sub x. Right there. Okay, B sub z, C sub x, A sub y. Okay, there we go. So those are our 3 positive terms. All right. Next, the negative terms, negative B sub z, C sub y, A sub x. All right. Next, negative B sub y, C sub x, A sub z. Okay, and then finally, minus B sub x, C sub z, A sub y. Okay, so yeah, we have exactly the same terms. Of course, you know, the order of adding doesn't matter. The order of the multiplying within the terms doesn't matter. So we've got the same 3 terms. All right. Now, what we could do, if we really wanted to, is we could try this determinant. Okay, but I hope you can convince yourselves now that we can cycle things through in this order. In other words, if we can cycle, you know, A to the 3rd position, and then B to the 1st, and then C to the 2nd, then we can repeat the procedure in which we would get this expression, C dot, the grouping A cross B. Okay. But try it on your own if you want to see how it works the third way. But mathematically, I think we've proven what we need to. Okay, this result, this of the cyclicity, if you like, of this scalar triple product or triple scalar product, used a lot of times in physics and engineering. Okay, I'm sure you get to use this once in a while in some pure math as well. But there you go. Hope this is helpful. I would love it if you give me a subscribe to the channel. You share this video with some other students or friends who are interested in the same sort of thing. Thanks for hanging out with me here, and we'll see you again next time.